Okay, so this picture is from Armand Bayou. Many of you know I live fairly close to there and spent quite a bit of time out there on the kayaks. This was a beautiful winter day, and the tide happened to be low, and we saw a exposed mud flat that was just full of Rangia cuneata, big ones. And it was like the Bellagio fountain because they were all deprivating, and so they were spraying water up in the air. It was really cool. So, in any event, so we're now in the very last section of the course outline. But this is a three-part series. There's quite a bit to talk about here to round out the semester. So this today is the first part of three. Um, by the end of all of these, you should be able to explain why wetland restoration is sometimes necessary and required. You should be able to compare different methods of restoration, how ecosystem structure and function are included in the design and assessment of habitat restorations. You should be able to describe the concept of restoration as mitigation and analyze if it's worth the effort and expense, especially relative to preservation, which we're also going to talk about. Okay, so pardon me, I've got three screens actually going, but two that are relevant to this. Um, so I, I want to kind of set the stage here. So we live in the Galveston Bay system, and I utilize that as my kind of primary um, uh, setting, so to speak. And so you would have seen this before from me, but as a reminder, Galveston Bay has lost well over 100,000 acres of estuarine marsh, and that was back in 1995, which you saw from some updated data earlier that those losses have slowed down, but they've continued. Um, there have been efforts to restore some of these wetlands, to protect some of these wetlands, and that's what I want to get into and talk about today. So, why is this giving me trouble? I do not know. All right, there we go. So let's define a couple of things. First, structure. So structure really looks at community composition and the way organisms are organized, right? So we've talked about this before, and you should have covered this in other lower level courses, I would think. So that would include things like species composition, richness, diversity, how those species assemblages are configured, right? So because we talked a little bit about evenness, community evenness, and the relative proportion of abundance in those different communities can speak to function to some extent, as one example. And then, well, like I said, the relative distribution and abundance of those assemblages. Function is how each element in the landscape interacts based on its life cycle events, right? So all of these different organisms are going through different life cycles. The timings of those life cycles are sometimes different, and those life cycles then affect the function of the community as a whole. So this would include processes, roles, and services. And there are examples such as the nutrients that are assimilated by plants, which would happen when the plants are in their active season. When they're in senescence, that's going to be less, so there's going to be differences there. When predators are eating prey, so on and so forth. Okay. Um, all right. So as I mentioned, we're primarily going to talk about restoration today and over the ensuing two more discussions. However, I also want to talk a little bit about habitat preservation. I think it's important to look at preservation kind of as your baseline or your control whenever you're talking about habitat restoration, right? So when you're preserving habitat, you're maintaining the existing structure and function as is, all right? And this is primarily applied to habitats that are relatively pristine, okay? In other words, we're not going out and preserving brownfields. we're going out and preserving um, uh, ecosystems that are highly functional and representative of the best of those ecosystems. And this is the same in wetlands, right? And the objective is to do so in perpetuity. Right? So when we preserve something, we want to preserve it for future generations, all future generations. And that includes not only the habitat, but the functions of that habitat, right? Habitat restoration, on the other hand, is when you have something less than that, right, that you're starting out with. And so this is where we're going in and we're trying to increase the structure and function through some sort of intervention, right? And so that might be planting, it might be invasive species removal, it might be any number of different things. And here again, wetlands, it's the same thing, right? So we're talking about with wetlands a specific type of habitat, but it's a degraded wetland. It might be a former wetland. So if it's a wetland that has been drained for some reason or filled, then we want to take it back to a pre-existing condition or as close to that condition as we can get to that. And then the very end of that is habitat creation, and that's really where we're creating something new. So you see this sometimes where uplands are dug out and they might be converted into some sort of wetland feature. And this can, again, be across habitats. So you might see forests planted where there weren't forests before, or you might see forests cut down and grasslands created. You can essentially take anything and turn it into virtually anything else if the climate is appropriate, and that's true with wetlands as well. So you'll see all three of these things in the Galveston Bay ecosystem. So if we look at this graphically, right, you've got function and structure and complexity and the objective is that, you're taking with restoration, you're taking the degraded system and you're trying to make it function and resemble the original system. Which, if the original system was there, we'd just be trying to preserve that system. But in the event that system is impacted or destroyed outright, then we want to take that degraded system and try and get it to move forward. So, um, you know, one choice is always don't do anything. If you look at it and it's just you're just going to let it continue to degrade. And generally, when you have a degraded system, if it's highly degraded, it's going to continue to go in that direction. But that direction can be either worse, or in some cases, if some of the original community is there, there are instances where that community can be somewhat self-healing. So it may move somewhat back towards that original system. Restoration is designed to take it all the way. So instead of letting the system kind of do what it will, right, maybe degrade further or possibly not do anything or possibly kind of inch back towards the original system. The idea here is let's go in and let's take it to that back to the level that we want it to be at. Now, you will sometimes hear this other term, rehabilitation. Rehabilitation is you're fixing things, but you're not really restoring it back to its original function. It's more of an improvement than a take it all the way back to the original system. In some instances, there are choices to replace those wetlands. Replacement is typically taking one type and replacing it with something else. So that might be replacing forested riparian wetland or coastal bottomland with marsh, right? You're replacing with something that really has a different type of function. So through all of this, of course, there are going to be fluctuations. Seasonal fluctuations are the one we tend to focus on, but There are other, like we talked about, the life cycles of the organisms can create fluctuations within the community as well. Those seasonal fluctuations can complicate restoration and trying to get it back to back to that original system. In some cases, because it provides stressors that depending on the nature of the restoration, the nature of the system, and the extent of the extremes of those seasonal fluctuations, that they can actually kind of stop you in your tracks in some instances. I'll use an example. The last couple of years, we've had a fairly significant drought, um, and that has altered salinity regimes in the lower bay. It has had some significant impacts on rainfall. And in areas where we've done recent restoration, we've seen the growth of that restoration, both in terms of biomass of the plants, but in terms of volunteers within that species and in new species coming in to that restoration site slowed significantly as a result of that seasonal fluctuation that in these last couple of years has been really extreme. Here we go. Get my buttons working here. So, a lot of options, right? Preservation, restoration, um, rehabilitation, replacement, and neglect. Always options when you're looking at any sort of restoration project. And I like to compare or liken restoration to custom cabinets, right? You're not going into Lowe's or the Home Depot or wherever and just getting, off the shelf cabinets and sticking them in there. Every project is custom, and you have to determine what's the right thing to do in this circumstance. And there are a lot of things to consider there just besides what the end result in terms of the community is going to be. You have to look at the resilience of that community over time. In other words, if you build something, but it's in an area that is very prone to sea level rise and you can't actually fix that as part of your particular project, that may not be the right place to do that project or to do it to the extent that you originally intended. So you have to really there's a lot of effort that goes into determining what you're going to restore and how you're going to do that, or which of these actions you're going to take. In some cases, um, you know, restoration may not be the right endpoint. It might be replacement with something else, right? Or it might be rehabilitation to get some temporary gains while you work through your options to determine what might be achievable in the long term, maybe in that area or maybe somewhere else with the same funds that you have available, right? Because that's part of it. These projects, I've worked on a lot of $1 million plus projects, and by today's standards, those are not even very expensive projects. But with the funding that's available, you really have to pick your projects and make the most of the funds that you have in order to be successful. So again, these options are a good menu of choices from which to select. All right, so let's run through these in a little more detail, right? So preservation, this is the highest level, and I will tell you as a professional, if this is an option, this is the best option, right? If you can do this, you have a system that is at its functional climax. So it is every ecologic niche that can be filled is filled. This is a great way to go because it protects those existing functions and values without the lag time that comes with a restoration type project, right? The other thing is that when you preserve something, there are tools in which you can prevent future development or impacts. And that could be done in perpetuity, essentially forever, right? So an example of that would be conservation easements, we're going to talk a little bit more about, or sometimes just fee simple donations to government agencies, entities, or in some cases, nonprofit entities that have the capacity to be able to protect those. So think about the big guys like the Nature Conservancy, right, that owns a lot of conserved properties. And those properties, nobody's going to develop on those properties, right, as long as the Nature Conservancy is around. Um, In some cases, which choice you make might depend on the individual circumstances. Sometimes a conservation easement is a better way to go, especially if there's some chance that the property might change hands as we move through the future. That easement can help lock that down and keep it in its current status. Um, as intended by the landowner, whoever you're working with to do that. So anyway, we'll talk a little bit more about that as we go. All right. So these preservation properties also often serve kind of as a basis for similar preservation and restoration in the same area. So you'll see them utilized a lot of times as a control. So if you're evaluating a restoration site, and you're trying to restore it to something that you have on a preservation site, that can be a good control against which you can measure to determine, if how your restoration site is performing, and you can also adaptively manage it based on that site as well. So as I said, preservations can be fee simple. Or they can be through easements. We do have local examples of that. So, the Armand Bayou Nature Center, which I like to use a lot as an example, it's owned outright by the Nature Center, right? Actually, it's through the county. So they have all title and responsibility, and they manage it as they see fit to meet their conservation goals. An easement really separates the owner from the easement holder. So you have an owner of the property, and then the easement holder is a separate entity that has two real functions. One is to monitor the property to ensure that it is meeting its conservation goals, whatever those are. And then they also have some enforcement and compliance mechanisms so that if for some reason the property owner is not maintaining it as stated in the easement, then the easement holder has the authority and funding to pursue that landowner in order to ensure that they maintain they're compliant with the easement, right? This is particularly the case in places like where you have mitigation properties, offsets, where somebody impacted a site and they had to restore or preserve something else. And with preservations, then you want to be sure that that site, no matter who happens to own the responsibility of the property, that there's a separate entity that's charged with ensuring that that is going to be stewarded the way it was intended when that easement was set up. Other times it is, it's contingent in order to be able to get grant funds for some, especially nonprofit organizations. So an example in Galveston is the Artist Boat Coastal Heritage Preserve, which is owned by the Artist Boat. So they hold the title, and they steward the land, but there's a conservation easement on that property held by another entity that works with them to go out and do studies. And in this case, having a separate, in a case like this, sometimes having a separate easement holder that's actually going out and doing the evaluations on the property adds a layer of trustworthiness, I guess, for lack of a better word off the top of my head, that ensures that, if somebody's putting grant funds into doing work with this, that they're getting the most out of those funds, right? And that somebody's keeping everybody else honest. So there's just kind of a third set of eyes in there, right? Okay. So as I said, local preservation examples. This is from the Armand Bayou Nature Center. that's my youngest stepdaughter, clearly having a good time. So, and then the Artist Boat, as I talked about, but there are others. GBF, the Nature Conservancy, have like arrangements on the Pierce Marsh Preserve. Bayou Land Conservancy holds an easement and actually owns some property along the Spring Creek Greenway. Well, they own the easement. They hold the easements. Actually, don't hold me to only own the property. I can't remember that off the top of my head. I want to say that they do, but I might be incorrect at this point. In any event, these entities that hold these easements and or are conservation organizations that hold their own properties, the highest level of standard for ensuring preservation is through the Land Trust Alliance. And so organizations can be accredited. So this is an accrediting body that ensures that the organization has the capacity and the wherewithal to be able to negotiate easements, to be able to monitor and maintain properties if they're responsible for that, or to ensure that whoever is doing that is meeting the requirements of that easement. So you'll see a lot of times organizations like the Galveston Bay Foundation are accredited by the Land Trust Alliance, both for their own holdings that they own, in fee simple, and also to ensure the integrity of, that's what I meant instead of trustworthiness earlier, the integrity of the easements that they hold and enforce. So you can find the Land Trust Alliance and go to their website. There are a number of organizations, pretty much all of the land trusts in this area are accredited. And generally, the recommendation is if you are going to be entering into a conservation agreement, especially, or donating property, going to an accredited land trust provides better insurance that that property is going to be maintained the way it was intended over time. And part of that has to do with the way the accreditation process looks at how these entities are funded and how they maintain their funding, right? I have a friend that used to be the director of the Bayou Land Conservancy, and she used to say that conservation without funding is just conversation. And there's truth to that, right? If you have a land trust that holds properties and they go bankrupt, those properties then are no longer protected, right? If you have a land trust that is maintaining a conservation easement and it can no longer afford to enforce the easement, so the property changed hands, went from the original owners to maybe their kids who now want to build houses, cut the forest down and build houses, and the land trust doesn't no longer has enough money to be able to enforce the easement legally. Well, then there again, you've got a failure in that process. So the funding is a big part of this and how organizations maintain their finances, right, in terms of this accreditation. Okay, so then why would we restore? Well, we're going to restore something if we want to try and achieve those same targets that you would get through preservation, but we're not starting at the same place, right? So you're preserving something if it's already in that, in that awesome condition that we're really looking for. Restoration implies that it's something less than that and needs help, right? Okay, so this is generally motivated because we've lost something. So we're talking about wetlands, what kinds of things do we lose? Well, you know this already, but as a reminder, wetlands provide a lot of ecosystem services. And so these are functions that benefit us, right? They benefit other systems and other elements of the ecosystem. So, a lot of these ecosystem services are mutually dependent on each other. But ultimately, speaking anthropogenically, we look at these systems and these functions as what good things do they do for us? So they might provision food, they might regulate services like carbon sequestration or erosion protection. They provide a variety of services to, again, other parts of the ecologic community that we find cultural value in. So a variety of different things, right? So there is a field of study. Um, so this is restoration ecology, right? This field of study looks at how we restore degraded, damaged, or destroyed ecosystems through active human intervention. So this is the study of that work. Ecological restoration is the actual activity, and so this is when we're actually on the ground doing that restoration. And both of those elements are important to a successful project. Um, I would say, again, from personal experience during the course of my career, that I've seen a lot of entities that are really desperate to get plants in the ground, right? And so they will go out and even if they're doing some upfront engineering and some of the background work that needs to be done, there's not very much work done on the back end to ensure success, which I liken to having a child and after 6 months taking it out to the park, setting it on a teeter totter, and then walking away and maybe coming back, the next year, a year later, and looking, okay, you're still good. And then the next year, okay, you're still good. And that's it. Right. And that's just not realistic with your children for sure, but also with these wetland systems where you need this study, this ongoing study, not only on the front end in order to help with design, like we're going to talk about, but also on the back end so that you can adaptively manage because things are invariably going to happen. And these sites where these things are constructed change, and the consequence of that means that you've got to make adjustments sometimes as these systems are developing in order to shepherd them to where they are a functional climax community, right? Just like you're going to shepherd your children all the way until they're old enough to make their own good decisions and be, healthy, functioning adults. So it's that similar sort of process. All right, so true or false? Ecological restoration can involve the removal of non-native species. Yes. So I mentioned this in a previous slide, but in some cases, restoration can be quite simple, and removing invasive or other exotic species can allow the native species to retain their original level of function within that biologic community by removing the competitive advantage that often non-native species often have. Okay, so here again, we're talking about restoration. It's what we're doing is we're repairing and recovering lost habitat and functions. This can be coupled to land preservation or other habitat restoration, right? So if we're interested in wetlands, so we're, it's a coastal plant ecology course. So presumably if we're out there restoring wetlands, oftentimes you'll see this coupled to other restoration or preservation projects. This would have been some years ago, but I worked on a project down by Lafitte's Cove. And at that time, we were actually, no, it wasn't Lafitte's Cove, it was Snake Island Cove down that way. So if you know where the Sunset Cove subdivision is down there, that was a project where we had coupled land preservation with habitat restoration and recognizing that some of the areas we were preserving were well functional and they actually provided supporting functions that would allow restoration of degraded wetlands or lost wetlands, either directly because of the development of the subdivision or in some cases because of sea level rise and erosion and the other things that are going on the bay side of the island. Um, we were able to couple together everything from high marsh, kind of coastal prairie there on the backside of the island, all the way out to some seagrass restoration, right? So it was several different communities over a period of time where we were able to do quite a bit. And so you will oftentimes see restoration and preservation coupled together, and oftentimes across a variety of different habitats. It does take time, regardless of what you're restoring. It takes time for these ecosystems because you're really creating a living organism here. And just like it takes time for a child to grow to be an adult, it takes time for these restored communities, biologic communities, to achieve their peak ecologic function, right? And the time that it takes really varies depending on the nature of the ecosystem. I know I've mentioned this before, but forested wetlands are some of the most complex and difficult ecosystems to restore because of the length of time it takes for them to get from planting to peak functional habitat values. Um, I mean, we're talking multiple decades, sometimes 50 years or more. Even relatively straightforward wetland restoration, like low coastal marsh here in the Galveston Bay Area, where we're primarily working with Sporobolus alterniflorus, that you would know as Spartina alterniflora, as your foundational species. Um, those are considered to be relatively straightforward restorations, but even those take up to 25 years to actually achieve their peak functional values, and that's because there's all these processes of ecologic succession that occur. You have other species then that are moving into those marshes, and they have their own functions, and so you're building out ecologic niches. So there's it takes time in order for that to happen, and during that time, disturbance, whether it's from the actual construction to other things that might happen. So that might be storms, it might be unintended events of any nature. That can make them susceptible to all kinds of losses. But one thing in particular that can be problematic are invasive species. Where you have a disturbance, that's often a really good opportunity for invasive species to come in and colonize because they have competitive advantages. They don't have predators. In many instances, they're very well adapted to these conditions. And if they're already established in the area, it's pretty easy for that to come in. Project I worked on up in Texas City, um, they ended up with a real significant deep-rooted sedge invasion on a coastal prairie restoration. And the sedge was actually brought in on the mowers that were meant to help control other invasive species, also to provide accessibility. So disturbance of any nature can be really problematic. I know a lot of projects I worked on for things I was doing for the Corps in some of my consulting work. Um, that we often wrote provisions in as part of our evaluations for civil works projects to be sure that whatever contractors the Corps was going to hire to do this work, that they were cognizant of the fact that construction equipment and can often be a vector for invasive species. And you have to look at things like sea level rise and subsidence. You know, the um, one of the things that used to make me chuckle was some grant programs that were established here in the state. I will leave them unnamed, but I always thought it was funny because at the time, the governor of the state was very much a climate change denier, and there's a lot of pressure on state agencies not to use anything to do any terms to do with climate change. Evaluate that how you will, but the importance of it is recognizing that sea level rise and the changes in terms of precipitation and temperature in our area are measurable, and we have measures that go back decades, right? So it's it isn't really a discussion of personal beliefs. It's looking at data and interpreting that data. And one of the things we know is when we're going to do a habitat restoration in a coastal environment, we have to figure that the sea level is going to continue to rise, right? We're in an area where it's already rising faster than most other places around the entire Earth here in the Galveston area. So you've got to account for that. So when you're doing your construction, the engineering of that needs to take into account that those future projections for sea level rise or relative sea level rise in areas where we have subsidence, in order to be sure that the money and effort that you're spending to restore this habitat is going to allow that habitat to actually get to its peak functional value, where then perhaps it can keep up with that on its own, right? You have to build in those accommodations, though, otherwise you're not preparing. And Benjamin Franklin said, failing to prepare is preparing to fail. So, right. So you need that, and it's in today's political climate, sometimes that's difficult. You've got to kind of work through those things as you're trying to build out funding and make sure that kind of stuff happens. Okay. One of the things I want to point out in relation to that last point is that there is quite a bit of research in Galveston Bay. I've done some of it, but some of the really telling and foundational studies done in Galveston, Tom Manello and Jim Webb. Jim used to teach at A&M. And Larry Rosas have done several studies, and they were fisheries studies looking at fisheries usage of some of these constructed marshes, including the marsh there behind the Galveston Island State Park. And what they found is similar to what all of us have found, that in many instances, these created marshes or restored marshes, either or, their functions are often reduced when we compare them to a natural unrestored marsh, so something that would have been preserved, right? Part of that has to do with the lag time. Again, it takes a long time for these marshes to achieve their peak functional value, but in some instances, it's really hard to recreate nature. Whether you're doing a restoration or an outright creation, it's a challenge. So we'll talk more about this as we move forward over the next couple of presentations. All right, so we've talked a little bit about policy. We had some discussion over no net loss of wetlands. So for every acre of jurisdictional wetlands under the Clean Water Act that's lost, at least 1 acre must be created or restored. That one-to-one policy. We also talked about how that can be modified under certain circumstances based on functional analyses. So the idea here is to eventually increase those wetlands. So wetland restoration and creation are common techniques for developers to adhere to this policy, right? So okay, I need to fill this amount of wetland in order to achieve my ultimate goal of having this coastal subdivision with canals in it. So in order to offset the impacts to wetlands here, I'm going to create wetlands over here in this field, or I'm going to restore wetlands that are coastal on either side of my property, or maybe on this island that's out in the bay. So that's the idea there. So here then, how do we do this? How do we accomplish this wetland restoration? Well, there's this construction phase, and I almost put in here, really, there's a planning phase that actually goes before we actually start construction, right? In that there's a lot of design that goes into these and a lot of engineering that has to go into creating, especially at the large scale. So when we're talking about these projects that are sometimes hundreds of acres of marsh, if we're going in there, we need to understand what is the quality and consistency of the underlying soils or sediments. What is the nature of the wave fetch in that area? What are the prevailing winds like? What's the depth that we're working in? What are the tidal exchanges? Is there a sediment budget in that area? And we have to study all that so we have an idea of what the best approach for construction is going to be in order to achieve the goals that we're trying to hit. All right. So in some instances, if you have an area that part of that marsh is going to be exposed to a significant wave fetch during when we have these northers come in, which is often the case on the bay side of Galveston Island, then you have to incorporate in those instances some sort of protective, sometimes sacrificial erosion protection, right? To give the marsh that you're constructing time to establish in order to protect itself, right? So these are the kind of things that we have to consider as part of that. And then it's a matter of going in, and there are a variety of techniques. We'll look a little more at these as we discuss this, as we unpack this. But generally, you're going in and you're moving earth, right? You're going in and you are working to restore conditions that would support the habitat that were previously supported in that area if you're doing a restoration, or creating those conditions in environments where maybe you never had that particular habitat, but you've determined this is a good place to make this work to replace lost wetlands in another area that just is no longer suitable. Okay, so And then there are a variety of methods to go in and plant that where you're creating these marshes. What you're seeing here in this picture is my laser pointer working. Hey, look at me. Here you're looking at, this is a community restoration. So this involves volunteers from the community to come out and plant. They're doing a working through a process called sprigging. We'll talk about that as well. So they're going and planting these actual stems. The nice thing about using volunteers from the community where the restoration is occurring is it helps not only educate the community, but also then um, uh, kind of integrate some ownership over that project so that people that were involved in it, they tend to stay involved and they tend to get involved in other things that are related. And third, and maybe most important, they get other people involved that weren't necessarily involved in the first place. So there's this kind of, I don't know, kind of cascade effect that occurs. And I think I was going to say trickle down, but that isn't right. It's kind of a cascading effect that happens. So that can be really valuable. Um, this is a tedious process, though, when we're talking about plants, because in many instances, um, you're not able to just go out and pull plants from one place and stick them somewhere else. They have to be cultivated. And so these are photos, actually, these are some of my students out from Lee, not, yeah. So some of my students from Lee. And the Galveston Bay Foundation has a wetland plant nursery here that they operated in conjunction with NRG and the Natural Resource Conservation Service of the USDA. And so they cultivate a whole variety of different plants to do restoration um, of a variety of different types. Low marsh restoration was their initial primary target, so they grew a lot of Spartina there. But they grow a lot of other things. Mangroves, my students have transplanted, I can't even tell you how many mangroves over the years working there in the greenhouse. But all variety of marsh species at all levels of these marshes. But this is time consuming work. So these plants might need hands-on cultivation for 2 years or more in some cases before they're ready to actually go plant. So where you saw in the previous slide where you saw people out there actually planting, a lot of times there was a year or more of effort on the front end of that, getting the plants ready to actually go out to the marsh. So again, one of the reasons why restoration is a second choice for me personally as a practitioner, if preservation is available in any given situation, is I like to focus on preservation first because it's more cost effective in most instances, and because the community is already at its peak functional value, it's easier to protect those than it is to try and restore those. It's like my grandfather says. I think I'm full of sayings today. So, like my grandfather said, an ounce of prevention is worth a pound of cure, young man. So, in any event, that's not to say I don't think restoration is good. I think we need to continue to be restoring because we need to replace what's already been lost that can't be preserved. But in many instances, there's an opportunity to do preservation, and I think looking at that as the priority, and then restoring on top of that is oftentimes your best bet. Um, okay, so there have been a lot of restoration projects. This slide is just meant to kind of give you an idea that restoration has been done all around the Bay. These are just Galveston Bay projects, and this really doesn't include anything past, I think, about 2005 or 2007. So these have easily been doubled. And in many instances, there's ongoing restoration in some of these. So for instance, Pierce Marsh has had a number of projects done within Pierce Marsh since 2001. And we're actually going to look at some of those. So a lot of different projects, and again, each project is unique. It might look at different types of habitats. So some of these projects involve low marsh, some of them involve coastal prairie, some of them involve seagrasses, right? Some of them needed temporary structures in order to serve as wave breaks until they established. Some of them, there are different designs. We're going to look at some of those different designs. So a lot of work in this particular area. And this is guided by a number of plans across a number of entities. The one that is, I think, the overarching plan for Galveston Bay is the Galveston Bay Plan. And so this was developed by the Galveston Bay National Estuary Program back starting in the late 80s and into the early 90s. They commissioned a tremendous range of studies to be done on Galveston Bay to assess what needed to be done. And at the end of that, they determined that loss of habitat in Galveston Bay was the number one challenge that we were facing at that time. And so protection and restoration of that habitat was the number one objective. Um, there are a number of other entities. The Galveston Bay Foundation, of course, is our local, one of our local nonprofits that's really important in this goal. Not the only one, but certainly a big player. They are one of the founding members of Restore America's Estuaries, which is a national organization. And Restore America's Estuaries has a goal to restore over 1 million acres of wetlands nationwide, to which they're making good progress. So GBF has the stated goal of preserving and restoring about 24,000 acres. So just a small proportion of that in our area, but that's still a remarkable achievement. If they do that, they'll go a long way towards restoring and preserving wetlands, but restoring specifically wetlands that have been lost since the 1950s. Once you start doing this, so again, these are students of mine. This is a project we did up in the Burnett Bay area, which, if you know where the Lynchburg Ferry is, up in the upper part of the San Jacinto River. And again, this can be really time, energy, and resource intensive. So we were having to ferry plants out. Here again, we were sprigging, we're ferrying plants out in boats. And using volunteers. In this case, my students weren't all of the volunteers, but they were a big component of them. And so that's what we're doing is they're using something called a dibble. So you can look up dibble, D-I-B-B-L-E. And a dibble is it's used in forestry actually. So it's a little stake. I should have a picture in here of it, but anyway, you can find it on your own. It's a T-handled stake, and you push it down the ground, and it creates it's a wedge shape, and so it creates kind of this wedge. And then what foresters do is they just drop a little seedling tree in there, and they just kind of step on either side of the hole, and it closes it back up, and they go on. So it's a pretty for doing something by hand, it's a pretty energy effective way of doing a lot of plants in a single day. So that's been adopted for wetland restoration where you're using plugs. So here these students are out there and they're using that dibble. Now the tide was really high on the day we were out there doing the planting. That may be one of the highest tides we've ever tried to do sprigging that I can remember. Oftentimes we're doing it in much shallower areas, and normally that area is much shallower, but we had a really strong sustained southeast wind for a long period of time, and it just really pushed the water up into the bay. So here you can see it pushing down on the dibble, and they're going to put the plant in the ground. So, all right. As I mentioned, with these projects, there are a lot of different approaches for how we are going to restore a given marsh. Again, custom cabinets. So that can be, this is actual diagrams from the backside of Galveston Island from a project that we worked on at GBF in conjunction with Texas Parks and Wildlife. Gosh, I think U.S. Fish and Wildlife was involved, NOAA. In any event, so you can see there's mounds. So they're creating, this is one type of restoration, creating these different kind of mounds that you can see in this aerial down here. But these are then protected by geotubes, right? So these are essentially giant nylon tubes that they pump full of sand that they dredge off of the bottom, which has its own impacts, by the way. But that is then to provide protection from wave fetch, especially from those northers that blow in during the winter that catch a lot of water off of Galveston Bay, and they create these waves that just can chew up unvegetated soils on the backside of Galveston Island. So the idea is, let's protect these plants long enough for them to be able to establish, start modifying the soils, build their root structure, and then also start to colonize other species mixed in with the Spartina. And that can take a few years. So oftentimes these wave breaks have to be designed to be there for 4 or 5 years in order to allow those functions to start to function, sometimes longer. Um, okay, so one common technique that has been applied you see this in a lot of different places. There's a couple of examples I can think of here in Galveston Bay. One is Pierce Marsh that we're going to look at. The one of the initial restorations done behind the Galveston Island State Park used this method as well. It's called terracing. So this is borrowed from farming. All right, this is an agricultural practice where you build this mound. And the typical approach is you take out, I showed you in a previous picture, it looked like a backhoe. They call these marsh buggies. So they've got these great big like tank tracks on them, and the tank tracks allow the buggy to get out on the water. Sometimes they'll go out on barges as well, but then they use this backhoe to dig out a pit in the underlying surface, and they stack it up and they make this terrace. And then you plant in the intertidal zone of the terrace. Sometimes there's a cap on there that has oyster shell, right, that can be used for colonial water birds. Sometimes not, depending on the design features of this. This would be a pretty steep and narrow terrace, kind of like what this was actually a colleague of mine when I worked at the city of Houston, and then he went back to finish a degree at the University of Houston Clear Lake, and was actually on one of my grant funded projects. So in any event, this is a pretty narrow terrace here, but this is a terrace. Here's another different design. So this one is not a grid type, it's a different type, but same kind of idea. But one of the things you might see it's a little different here is the height and the sharpness or how steep the slope is. And that can have a significant impact on how much intertidal zone you have, how much edge essentially. Whether or not you can utilize the cap as a roosting site for colonial water birds, all that kind of stuff. So one of several different things we're gonna look at. Now, in these techniques, when you look at these techniques, so this is a satellite image of Pierce Marsh. So this is up I-45, just north of Galveston. So when you're going up I-45 and you go past Bayou Vista, this is Bayou Vista. So those are those canals. Here is Highland Bayou coming down here. And so this marsh, it has been the site of a lot of habitat restoration, some of which you can see in here of different design types. And we're going to talk more about Pierce Marsh specifically, but I want to focus on the different approaches or techniques because, I spoke to this a little bit earlier, but the fact is that these techniques can range from relatively simple. So terracing, like I just showed you, is considered to be one of the most straightforward, simple approaches towards habitat restoration. And so here you can see terraces. This is a grid type of terrace. Here, right in this area, you can actually see these little zigzags. Those are terraces also. So there's different types of layouts of terraces, but the underlying method or technique is the same. These tend to be the least expensive types of terraces or types of habitat restorations in marsh environments. But the downside of that is they also tend to produce the least vegetated area. So for every acre of restoration site, the acre of vegetated area you get tends to be a pretty low ratio, like 0.03 to 1 on the low end. And that fringe, that linear fringe that you get, so the intertidal zone that's the most productive in terms of aquatic habitat values for fisheries, for instance, it tends to be the lowest as well. And then as you get to these things like the mounds that I showed you are unconfined or confined fill, so that's kind of what you've got going on in here. or the creation of outright islands that we've done in some areas out in West Galveston Bay. As the cost goes up, the vegetated area goes up, and the fringing marsh goes up, because these tend to more fully, let me see if I can find my words here. These tend to replicate natural marshes more closely than these do, right? And so if nature is your objective, then these tend to be a closer replication of that when you're restoring that habitat. Okay. Whew. All right. One of the biggest problems we have with all of these marshes, and you may be getting this from my discussion on this so far, is erosion. Um, these marshes, whether you're doing a restoration or a creation, oftentimes are at their most fragile when the process is starting, right? So if you look in either of these aerials, this at one time was marsh. If you go back in the historic imagery, you'll see that there were marshes here that subsided and then eroded and just went away. And so we've got some remnants of those marshes. But so to come back out here and try and restore this habitat, well, all of this bare ground is just ripe for is ripe for wave fetch to come along and take all that dirt and put it elsewhere in the bay, redistribute it, right? So the one of the hardest problems we have is, how do we keep it there long enough to get a healthy coastal plant community, right? Sometimes that might involve either a temporary or a more permanent wave break. Sometimes they are permanent wave breaks. You're going to put in some sort of barrier, maybe a gabion wall or something just offshore that will break up that wave energy before it hits the plants. So a lot of different approaches to this. And in Galveston Bay, we've got a lot of erosional forces. We've got a lot of things going on, and all of them have their own impacts. And sometimes they combine kind of synergistically, to use a toxicology term. They come together synergistically to even accelerate that erosion beyond what you would expect just from those two things, right? So one of the biggest ones, one of the most problematic ones in the bay proper are actually these cold fronts that we get in the wintertime. And remember, we've talked about this before when we talked about tides, how these fronts want to push that water out into the Gulf of Mexico. But in so doing, there's a lot of area here for the erosional forces of waves to build. And so by the time it gets to these areas, especially on the backside of these barrier islands, that they can create a lot of damage. And even here in West Bay, this looks relatively narrow compared to Galveston Bay proper, but this is a pretty significant open water body that creates a lot of erosional stress from these northers that come through here. The prevailing southeast winds that we have during the summer can have the same kinds of impacts on some areas along the bay, and especially along the beachfront. And then the ship channel itself sets up a whole nother layer of erosional forces, especially on the west side of Galveston Bay, as those container vessels go up and down there. I think I told you this story, but one time I was out in Little Cedar Bayou taking some sediment samples. It's probably 15 or 20 years ago. I all set up on the shoreline, had my DO meter and my cores and sample bags and all my stuff kind of set up, and I'm in the bayou, and I was up to my knees in my waders, and all of a sudden it was like somebody pulled the drain in a bathtub, and all the water's going out. And then I'm like, what the heck is going on? I'm looking upstream, and then just as I turned around, there's this wave of water coming in off from the mouth of the bayou, knocked me over, swept all my bags. That was a disaster. I probably added a whole lifetime's worth of microplastics to the sediments. Anyway, plastic bags going up the bayou. I'm knocked over. My waders are filling with water. I'm kind of struggling to get up, wondering what the heck happened. And I got up and I'm looking down. And then here again, I turn around, look upstream, and here comes that same bunch of water in all my bags down and out into the bay. Knocked me over again. It was ridiculous. Um, Needless to say, I did not get any samples collected that particular day. But what it was a container vessel, and it actually ended up being quite informative because that was an area that that system was highly degraded because the sediments were so disturbed by the erosional forces. That was an area when I was doing my benthic macroinvertebrate work in that system. Um, the those um, that particular biologic community was very depressed. Part of it had to do with toxins that were actually in the sediments, but a big part of it actually had to do with the disturbance from that particular wave action. That wave action can have those same effects on these coastal plant communities. And well, here you go, right? So these are both from Trinity Bay, so up near the Trinity River, and this is an area that gets a lot of wave fetch, especially in the wintertime. And you can see the undercutting that happens here. Now, up to this point, I've been talking a lot about these big, restoration sites like Pierce Marsh that are more traditional, kind of low marsh expansions. But there is a lot of focus on shoreline marshes, which oftentimes do have fringe associated with them, fringe marsh, but it doesn't tend to be as deep from the shoreline in, right? And but they are really important not only for their habitat values, but also in terms of the protecting against erosional forces, which can have really significant not only habitat impacts, but land loss impacts and water quality impacts. So just like I showed you with those large marsh constructions, when we're looking at living shorelines is the term. It's cost versus erosive forces, and so the more energy and erosive force you have in an area, typically the more complex your project is going to be, the more wave break you're going to need, either temporary or permanent, to protect that shoreline marsh while you get it established, and the more expensive your project is going to be. But you have to evaluate those things. Again, I go back to kind of pre-construction. You've got to spend the time doing the design on the front end in order to ensure that you're going to get to the end objective that you're looking for. I want to spend just a second on this. I think over the last 40, 50 years, especially in Galveston Bay, when you're trying to protect the shoreline, the default has traditionally been to put up some sort of bulkhead or seawall, a hardened structure. And in part, it seems very straightforward. It's an easy thing for contractors to come in to do. It does not take a lot of engineering to do this, or at least on the face, it doesn't. It actually does. But most residential type of bulkheads are not anywhere near as well engineered as their industrial counterparts that you'll see along ship channels and where you have barges and major ships docking. These things are relatively simple, low cost, and not particularly durable approaches to shoreline stability management. And we often see them fail, as you see here. So this is again up in Trinity Bay. This is a bulkhead that was put in front of a residential property, and it had a little bit of undermining during Hurricane Harvey in 2017, and then it just collapsed over the ensuing years. So, in many instances, bulkheads create other problems. They can actually reflect a lot of the wave energy that hits the face of the wall, and they reflect that back out onto the adjacent marshes, either across stream or adjacent to the property itself. And the consequence of that is it accelerates erosion in those other areas. Dickinson Bayou, if you were to go up and down Dickinson Bayou, 15, 20 years ago, may still be that way. I haven't spent a whole lot of time there lately, but there were a lot of old wooden bulkheads that were built in the 60s and 70s that they are actually separated from the shoreline, um, because they eroded around the edges and then failed from behind. And so there's just a wall kind of out in the stream, and you'll oftentimes see cuts in the shoreline either side of where that wall had been, where that erosion was accelerated the most often. Oftentimes, you can also see accelerated erosion across the stream, depending on the nature of that particular stream. Um, so the approach that we're taking more and more often, and I'm seeing more contractors doing this, but this is on a national scale has really taken off over the last 20 years. Um, and in Galveston Bay is quite has gained a lot of traction as well. So here, this is off of Eckert Bio down on West Galveston Island. I want to say this is up in the Trinity region, if I remember correctly. In any event, these are living shoreline sites that this is one that I've done monitoring on. This is one that I actually helped in construction of. It's the one I'm thinking of. In any event, you can see here that in both instances, there are wave breaks that are involved to kind of help protect the marsh initially until it gets established. In some cases, this can be an opportunity for oyster development as well. This is certainly the case in Eckert Bayou, and I know they're trying to do a little bit of that up in Trinity Bay as well. It's a little more difficult up in that area, but um, you can see then that what happens is the marsh establishes behind that. In some cases, the wave break can be instrumental in sediment or soil accumulation behind that. Perhaps the soil slows the water down, allows the sediment particles that are suspended to drop out. That aids the plants in terms of building the marsh. So these are a couple of approaches. And what I want to pick up with next time is I want to start to look at the actual planting element of these restoration projects. Okay, so with that, I'm looking forward to it, and I will see you next time.